Hello, welcome back. So we are getting closer to the end of the school year, and we're going to keep going, continuing with our EOC review. This is a review of all the content we've covered in Algebra 1 this year. Today we're going to start off the lesson talking about writing linear equations when you are given some of the information. So let's go ahead and jump right in. Our first set of questions here talks about when you have a point and a slope. So you have a point and the slope. So you know what the m is and you know what one of the points are on that line. The thing that you're missing here is you're missing the y-intercept. So you don't know where the line crosses the y-axis. But you can easily find that by plugging some stuff into the formula. So if the equation in slope-intercept form is y equals mx plus b, well, right here you have x and y and m, meaning you have x and y and m, and the thing that you don't have is b. So if you can solve this equation for b, then you can write an equation that fits this line that could be used for any point. So here we go, we're going to do one. Switch back to my drawing tool here. Awesome. Okay, so in question 1, we're given the point 2 and 7. That means we have x is 2, y is 7, and the slope, which is m, is 3. So let's plug in what we know. That would be 7 equals 2 times 3 plus the y-intercept, which is b. So if we solve this equation for b, we're going to get 6 plus b. 2 times 3 is 6. And so obviously the answer here would be b is 1, because 6 plus 1 would make 7. So I can use, now that I know the m and the b, that means the equation of this line is going to be 3x plus 1. And that's it. That's all there is to this. So you guys can do 2 and 4. I'm going to do number 3 with you, just as one more example. So we have a point 4 and negative 2, that's x and y. And we have our m, which is negative 1/2. So that means if we plug in this information, this is straight from the formula, y equals mx plus b, okay? If we plug this in, we're going to have negative 2 equals negative 1/2 times, that's m, and then we need to multiply that by x plus b, okay? So let's solve this. So negative 2 equals, well, half of 4 is 2, and if it's negative, that would be negative 2 plus b. Well, if I add 2 to both sides to cancel this out, then I get 0 equals b. So that means that this line crosses the y-intercept at 0. So this is actually an easy one. You would just do y equals the slope, negative 1/2 x. And then for b, you would put plus 0, but since 0 doesn't have an effect on it, you would just leave your answer like this. And I will box my answer on both questions. Boxed. I'll use green so it's a little more obvious. Okay, cool. All right, you do 2 and 4. Next section, writing linear equations given 2 points. So you don't know the slope. You only have 2 of the points that are on the line. So you don't know the slope and you don't know the y-intercept. These directions say use the slope formula followed by point slope, and I don't like that. I mean, it works, but it's one more formula to memorize when you can just use slope-intercept form. So we're going to actually cross this out. I want you to make sure you're doing this on your paper too. Cross this out, and you're going to put slope-intercept form. So we need to find the slope, which is m equals y2 minus y1 divided by x2 minus x1. We're going to have to use those coordinates from both points to figure that out. And then after we're done, we're going to use y equals mx plus b to get the y-intercept. And then we can make an equation with both pieces because we need m and b. That's the whole point of all this. Okay, so this is going to be x1, y1, x2, y2. I'm going to zoom in so you can see this a little better, or I'm going to try to zoom in. Okay. So first things first, let's find the slope. Okay, and if we find the slope, that would be m equals y2 minus y1 divided by x2 minus x1. Now, notice I put a plus here, and I did that for a reason, because it's going to be minus minus 1, and minus minus means plus, so it's plus 1. Okay, so solving this, we get negative 8 divided by negative 2, and if we solve that, we get positive 4, okay? Next thing, we need to take one of the points, pick one. It does not matter. You can choose either one, it's up to you. I'm just going to pick this one and use this because this is m. So that means negative 7, and this is just like what we were doing in those last problems, right? Negative 7 equals 4 times negative 3 plus the b, which is the y-intercept. So let's solve this. Negative 7 equals negative 12 plus b. And what do you have to add to negative 12 to make it negative 7? You have to add 5. So there you have it, and your final answer here is going to be y equals 4x plus 5. And we'll box our answer. I'm doing this by using the slope-intercept form, right, where I need to know m and b. So once I solve for m and once I solve for b, I can plug that into an equation where it can be any combination of x and y, okay? Let's go ahead and do 3. I will use the same color scheme here. So slope is going to be y2 minus y1 over x2 minus x1. This is 5 over 3. That doesn't simplify, so 5/3 is your slope. 5/3 is the value of m, that's it. Okay, now pick any point. It does not matter. You can choose the first one or the second one. I'll use the first one since I used the second one last time. I have negative 3 equals the slope, which is 5/3, times the value of x, which is negative 2, plus b. So let's solve this. Negative 3 equals, to multiply this fraction by this whole number, you just multiply it across the top and keep the same denominator. So that would be negative 10 over 3, and then we need to add the b value to that. Okay, so this gets a little tricky because now you have to add 10/3 to both sides, because then this, oh my god, why is that zooming like that? Sorry. Then this fraction will cancel, and you'll be left with b equals negative 3 plus 10/3. How do you solve that, right? So you need to solve that, right? So you need to have a common denominator to add these. So let me switch colors here. Let's do like orange, right? So I'm going to use the space at the bottom of my page to show this. So if I made this negative 3 be divided by 3, so really negative 3 is negative 3 over 1, right? Plus 10/3. So to have them have the same denominator, you need to multiply this bottom part by 3 and this top part by 3. So this transforms into negative 9/3 plus 10 over 3, which is negative 9 plus 10 over 3. And I'm allowed to do this now because they have that same denominator, right? So this becomes 1 over 3. So the b value is 1/3. And now you have the m and the b. So you can write an equation which will be y equals 5/3 x plus 1/3. And that's it. So you guys go ahead and take care of 2 and 4. Remember, for these assignments that you're turning in for this review, I'm giving you a grade on getting the notes part down. That's the stuff we're doing together. And then I'm giving you a separate grade for doing the practice problems, which are the ones with this orange border around them. And then there'll be a Delta Math assignment that goes over some or all of the concepts from the notes, and that's a grade as well. Okay, so make sure you're doing all 3 components here, all right? All right, let's flip to page 2. We're gonna shift gears here, and we're gonna be talking about systems of linear equations. So, okay, a system, we're gonna define that. We'll use blue. No, let's use purple. We haven't written in purple in a while. It's a system of equations is two linear, I don't know why I wrote an O, two linear equations that are on the same graph. And the possible solutions for a system are one solution where you have one x and y value that works in both equations. On the graph, the lines will be intersecting at one point. You can have no solution or none. That's when the lines are parallel. I apparently can't draw today or write, so we're going to just erase that. Okay, done. And you can have infinitely many solutions. And that's when they are the same line. So if you were to draw a picture of the graph, I'll use a different color for this. This would be like an X because they will intersect at one point. Or it could be none because they are parallel. Or it could be infinite solutions because they are the same line. And you'll only see one of them, or when you graph them, they'll be like on top of each other. All right, so we're going to solve some systems by graphing. I'm going to do one, then you're going to do one. So when we solve by graphing, what we do is we graph both lines on the coordinate plane and look to see if they intersect, if they're parallel, or if they're the same line, and that's how we know what the solutions are. So let's do, I don't know, let's use, I got an idea. Let's do orange for the first equation. So this will be orange. And I'll use green to represent the second equation, okay? So remember, when these are in slope-intercept form, they're very easy to graph because you just need to pick out the y-intercept and then use the slope to graph more points. So in the first line, the y-intercept is 2, so we're going to have a point here at 2. And then the slope is going down 3 and to the right 1. So 1, 2, 3, and to the right 1, 1, 2, 3, and to the right 1. Let me zoom this in so we can see this really good. Okay, and then we can also go up 3 and then to the left 1. Up 3 and to the left 1. And this should not be new for you because we did a review already about graphing linear equations. So we need to connect that. You can use a straight edge. Something that has a straight edge on it, or you can, I have a tool that I can just do on here that draws a line. I just have to like line it up correctly. That looks about right. And I can fix it too. I can like grab one side and like, whoops, we want to stay in full screen, thanks. Let's tap on this line. I can just grab one point and like, you know, make it look that much cleaner. And this one's probably like, oh dear, I've messed up my whole line. Okay, that's probably pretty good. Oh, I messed the line up again. Bam. Okay. Yeah. All right, great. Done. Okay, switch colors. We did green for the other lines. So the y-intercept is -6. You have a dot. The slope here is just 1. So it's up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1. Okay? So up 1 over 1, up 1 over 1. I think already we can see where the intersection point is. But let's just like really finish this problem really good because we're good mathematicians. And that's what we do. That looks pretty close. just gonna fix my ends here so it's like, that's pretty good, right? All right, so our intersection point is right here, okay? That's where the two lines intersect, and the intersection here means that there's one solution. So just what's the ordered pair that they intersect at? It is x is 2 and y is -4. So one solution, and it is 2, -4. Okay. I'll give you a hint on the second problem here. The second problem is also intersecting. So there's going to be one solution, one point. Graph that sucker on there and find where they intersect. And a hint for you also is that you need to change these into slope-intercept form first. That will be the easiest way for you to graph these. Okay, next section is about solving systems of equations algebraically, okay? So there's two ways we can do substitution or elimination. In most situations, you can really use either of them, and I'm just going to stick with elimination because I think it's like one less method for you to have to remember how to solve the equations with. So we'll switch colors. We're going to do blue. Let's zoom in here on our first problem. So we have x plus y is -4 and x minus y gives us 2. So let's find out what the solution is for this system. What we need to do is we need to have the equation lined up, meaning the x's are with the x's, the y's with the y's, and any constants you have are with the constants. That means you might have to move some stuff around potentially. And remember, this is that thing where you might have to multiply the top equation by something, or the bottom equation by something, or both of the equations by something in order to get one of the variables to cancel out. On number 1, there's really nothing that we have to do because if you look at this, a plus y and a minus y, those cancel each other already. So we don't have to do anything. This equation is already done for us. So let's combine these. And when I say combine or eliminate them, I mean let's draw a line and add them up and down. X plus x is 2x. Y minus y cancels out, and that's what we want. We want a variable to cancel. And then that equals -4 plus 2, which is -2. Let's solve this for x. If I divide both sides by 2, I get x equals -1. Okay, so we now know that the x part of our solution, so if I were to draw a little solution box over here, I know it's going to be a point, and I know the x value is -1. So what's the y value? All you have to do, and I'll switch colors to show it, all you have to do is take this value you just solved for x, because you know what x is, and go back and pick either one of the original equations and plug in -1 for x. So I'm going to pick the first equation, which was x plus y equals -4, but I know x is -1. And if I solve this, then I get y equals -3. And there's my other answer. And that's the solution for the system. There's one solution. If I were to graph these as lines, they would intersect in one place, and that would be the answer. Okay, 2 and 4 are for you guys. I'm just going to roll this down so we can see number 3 and do a different one where we actually do have to do a little manipulation here to solve this. I'll put a little solution box down here in the corner so we can keep track of our answer as we go. And let's get started. So I'll use blue to start. It's probably going to be a situation where I have to multiply both equations by a number in order to cancel something out. Like, for example, if I multiplied the top by 2 and didn't do anything to the denominator, none of the variables would cancel, okay? And also they're both positive, so I know I'm gonna have to do something with a negative here also. So it's really a guess and check type of thing. You have to get a little creative and you have to figure out like what looks like the easiest thing to multiply by that will cancel. I think that the y's will probably be easiest to cancel out, because if I multiply the top by 4 and the bottom by 3, well, negative 3 rather, then I'll have a plus 12 and a minus 12, and everything else will change too, but I know the y's will cancel. So let's multiply, let's do the changing, right? Let's change this up. We'll use red while we're doing the change it up part. So we're going to multiply this equation by 4, and we're going to multiply this equation by negative 3. Okay, so we now need to rewrite our system, okay? We're going to rewrite this with what the new equations look like, okay? So that means that the new equation on the top is going to be 4 times 4x, which is 16x, plus 12y, and then that's negative 4. I'm just distributing this 4 right here to every term inside here, and the same for this. This is going to be negative 15x minus 12y equals negative 3. Now I can combine them because the y's will cancel. So when I combine, I'm just adding up and down across the, across the equations. 16 minus 15 is 1x. 12y minus 12y cancels out, and this just becomes negative 7. So guess what? X is negative 7. Solved. Now I need to take this and plug it into an original equation. So take this negative, we have a shape for some reason, whoops. Let's take this negative 7, plug it into one of the original problems. Before you even did any of that multiplication stuff, just go back to an original equation. That's going to be 4 times 7 plus 3y equals negative 1. 7 times 4 is 28. Let's take away 28 from both sides. This cancels out. We get 3y equals negative 29. This is kind of ugly, but that's fine. Unless I'm adding correctly. Am I adding wrong? 7 times 4 is 28. Okay, so it turns out that, I made like a mistake. It happens. So this is actually a negative 7, and I forgot to transpose that negative sign right here. So this whole thing needs to be switched up. And I'm going to erase it all and do it again so I don't confuse you. Okay, so this is negative 28 plus 3y. Okay, now add 28 to both sides. You get 3y equals 27. Now, isn't that a nice clean number for our answer? Yes. Divide 3, and you get y equals 9. 9 times 3 is 27. So that's the solution to this system, negative 7, 9. Okay, you guys go ahead and do 2 and 4, and I'm gonna roll on to the last topic here. I lied, it's not the last topic yet because there's one more system to solve. You also have to do 6, so I'm gonna do 5 with you. Okay, so let's see. First of all, we want our variables to be on the same side, technically. So let's do that first, because I think that'll make it easier for us to read the problem that way. I'm going to use red to show this. On the second equation, if you look carefully, x and y are on the left side, and then the constant is on the right. That's in standard form. So I think we should probably make the first equation also be in standard form, and that would be changing the top one to x minus 2y equals negative 3. All I did was subtract 2y from both sides to do that. And then the bottom equation is still, I didn't change anything, so it's still 2y is negative 5. Okay, now that they're lined up, this is looking much better. I like this a lot better. It looks to me that the easiest thing for me to cancel here is going to be my x's, because this x in the first equation is just one x by itself, which means I can multiply it by -2 and then this will cancel out. Well, if I multiply that x by -2, I really have to multiply everything in the top equation by -2. So if I do that, then I get -2x plus 4y equals positive 6. Remember, negative times a negative makes a positive, and you need to distribute this 2 to this, to this, and to this, because you can't change one thing without changing the whole thing. Okay, the second equation stays the same, 2x minus 3y equals -5. Okay, now we're in a good shape here where we can, I'm going to make a solution box over here in the corner. Is my point. Okay, we're in a good spot now where we can combine or eliminate these equations, and I'm going to do that by getting rid of those x's, so these cancel, and then I have 4 minus 3, which is y, 1y, and 6 minus 5, which is 1, so the y value here is 1. Now, to get the x value, take the y equals 1 and go back to an original equation. I'm just going to go back to the first one, because why not? You can pick either one. They will both work, okay? So x equals 2 times 1 minus 3. X equals 2 minus 3. X equals -1. So -1. And that's my solution. Done. Okay, so you guys need to do 6 also. That's another practice problem for you. This is the 3rd page of EOC Review 3, Part 1, page 3. Okay, I think the last thing on here is word problems. That's true. Okay, so there's 3 word problems. We're going to do the first one together, and then the other 2 are for you guys. So let's do these. Aaron bought 4 jars of jelly and 6 jars of peanut butter for $19.32. Adam bought 3, that's funny, that's me, Adam. Adam bought 3 jars of jelly and 5 jars of peanut butter, $15.67. Find the cost of each. Okay, so what you need to do is you need to decide on some variables, right? So I think the number of jars of jelly, I need to make this a little bit thicker here, number 2, and do that again. The jelly is going to be X, and the peanut butter is going to be Y. And that's jars, right? So like jars of jelly is X, and jars of peanut butter is Y. So and it's the quantity of the jars. So Erin's equation is 4 jars of jelly and 6 jars of peanut butter, and her total was $19.32. Okay, so I just realized I misspoke a second ago and I said this was quantity. It's not, it's cost. I'm sorry. They gave us the quantity, so we know how many jars that they each bought. We just don't know how much the unit cost is. We don't know how much each jar costs. That's what X and Y are representing. My mistake, sorry. Okay, so we also have 3 jars of jelly, 5 jars of peanut butter. So the second equation will be for Adam. Okay, second equation is 3 jars of jelly, and I wrote over it so I can't see it. 5 jars of peanut butter. And his total was $15.67. Find the cost of each. So all you're solving for here is X and Y, because X is the cost of the jelly and Y is the cost of the peanut butter, okay? So we're gonna do some elimination method here. I think we're probably gonna have to do the X's, that's the smaller coefficients. So I'll use the color red. We're gonna multiply the top equation by -3 and the bottom equation by 4. And this will change our equation this way. You're going to need a calculator for this one to do the decimal point, maybe. Okay, so this equation is now -12x minus 18y equals 1932 times negative 3, negative 5796. Okay, the second equation is not negative positive, it's just multiplying by 4, so 12x plus 20y equals 1567 times 4 is 6268. Okay, now we can do elimination, right? We can do our, ew. Let's use a drawing, please. This Cami thing is like all over the place today. Okay, the x's cancel, so you have 2y equals, so negative 5796 plus 6268 is 472. Divide both sides by 2, and you get $2.36. So, or 2.36, but this is representative of dollars because y is the cost of peanut butter jar. So the solution here is, where can I write this? How about off to the side? Okay, so PB cost $2.36, and jelly costs, we don't know yet, let's figure it out. Switching to orange, we need to take 236 and go back to one of our original problems, like the first one, and plug it in. So 4x plus 6 times 2.36 equals 1932. 4x plus 1416 equals 1932. I don't have enough space to write this whole thing. Sorry, you're gonna have to use your imagination. I have to subtract 1416 from both sides, and then I have to divide that by 4, whatever that comes out to. So I'm gonna do all that on my calculator, divide that by 4, and I get x equals 129. So jelly costs $1.29. Okay. Now, one thing to note here about this problem is that for my other system of equations problems, I gave my solution as a point, a coordinate point, x and y. That's the correct way to do it. This is not an algebra problem that says, give me the solution to the system. This is an algebra problem that says, tell me the cost of peanut butter and jelly. So your answer should be represented as peanut butter costs this much and jelly costs this much. And the same is going to be true for 2 and 3. You're going to want to represent your answer as whatever the thing is that's going on in that problem, not just give me some numbers, okay? All right, so that's it for Review 3, Part 1. There's 2 word problems here for you to wrap up. And then there is a Delta Math assignment. If you're getting stuck with anything from this review, please come to my office hours. Those are on Tuesdays and Thursdays from 10:30 to 1:30. If for some reason I'm not having the room open the whole time, just shoot me a text or an email or a message on Google Classroom or something and just tell me you need help, and we'll open that room up and we will get you the help that you need. All right, thank you guys for tuning in. I will see you next time. Bye-bye.